and solving by completing the square. You're already familiar with completing the square, and you know that little rule, b over 2 squared. But today we're going to use completing the square to actually solve quadratic equations. The page of notes ready in your notebook. We're going to take some notes while we watch this video. First of all, we're going to recap some simpler examples of solving quadratics. These are all quadratic equations. They can all be solved. Since they're quadratic, each of them will have two answers. Let's begin with this simple one. We have x squared equals 9. Well, we can just take the square root of this side and square root of this side. However, when we take the square root of an x thing, the answer is going to be positive or negative. In this case, take the square root of that, and then on this side we have the positive or negative value of square root of 9. Square root of 9 is 3, so we have plus or minus 3. So our two answers are x equals 3 and x equals minus 3. Now just think about that. This means here something squared makes 9. Well, 3 times 3 makes 9, but also negative 3 times negative 3 makes 9. That's why we always add this plus or minus sign here to get two different answers. Next one, we have this. Very similar to the first one, but here we have 5x squared equals 30. This time we should get rid of this coefficient first before taking the square root. So I divide by 5, and I have x squared equals 6. Now I'm going to take the square root of both sides again. So that means x equals plus or minus the square root of 6. In this case, this was a perfect square, so we could take the square root of 9 and get 3. Here, 6 is not a perfect square. You could get a decimal answer by using your calculator, and it would be, I don't know, 2 point something, but we can also leave it like this. Since we have the plus or minus, let's write both our answers. X equals the positive root of 6 or x equals the negative root of 6. Now let's look at this one. In the third one here, it's a little bit different. In these, all we had was an x squared and a number. And here also x squared and a number. Here we have x squared and x. In this case, it's important to start thinking about the null factor law, which we saw in the last video lesson. And this basically means let's bring everything to one side so we get 0. So I'm going to move the 6 over here, negative 6x. Now I have 0 on this side. Now if I can factor this, I can use the null factor law. This is an easy factoring problem. You just factor out the x. So x comes out, we have x times x minus 6. Now we have two factors that multiply and make 0. That means each factor can be set equal to 0. If we set this factor equal to 0, we have x equals 0. That's one of our answers. If we set this factor equal to 0, x minus 6 equals 0, then when we solve that, we get x equals 6. There's our two answers. All right, what about one like this? This one's different than all three above. Again, this one had x squared and a number, x squared and a number, and then x squared and an x. This one has x squared, an x thing, and a number. So this is a trinomial. So with these, we do the same thing. We move the 6 over to that side. Here it is, to get 0 here. Now this you should recognize is very familiar. Standard form quadratic. When we have three parts like that, we should factor. That factors into this. So this factoring was easier, right? But this factoring is like that, and now each of these is set equal to 0, and we get two answers, negative 2 and negative 3. So that's just kind of a recap of solving different quadratics, but today's focus is on solving by completing the square. So what if we have one like this? So again, it's a trinomial. We have three parts, x squared and x and a 4. So I'm going to rearrange that first of all by moving this 4 over to this side, negative 4. I'm going to see if I can factor this. So remember your factoring method here, and a times c is negative 4, b value is negative 2. Now I'm trying to think of two numbers that multiply to make this, but add up to make this. Well, 1 times 4 or 2 times 2, but they don't seem to add up properly, so it doesn't work. In this case, it can't factor. So the last one we looked at in the last slide, it factored and we could solve it, but this one doesn't factor. So what do we do when it doesn't factor? Well, we know another technique of rearranging quadratics called completing the square. So we're going to take this and we're going to complete the square. First, move the 4 over here. Now we're going to complete the square on this part. So remember, when we complete the square, we do b over 2 squared. So that would be negative 2 over 2 squared. That is negative 1 squared, which is 1. So now our magic number to add to both sides is 1, right? We're going to put a 1 here on this side. And on this side, we're also going to add a 1 to keep the balance. This is now a perfect square trinomial, which factors into x minus 1 right here. And on this side, we have 5. Now this is solvable, all right? This was not really solvable. This was not solvable, but now that we rearrange it like this, we can solve it. We can take the square root of both sides. So we have x minus 1 equals plus or minus root of 5. Don't forget the plus or minus, two answers. Then we're going to take this 1 and move it over to the right side. So plus 1 over here. And we have x equals 1 plus or minus root of 5. In this case, there's two answers again. I'm going to write them both. X equals 1 plus root of 5, and x equals 1 minus root of 5. Those are two answers. Again, you could use calculator to get a decimal and make decimal answers of these, but this is okay. Leave it like this. Let's try one more. This example looks like this. Again, we have a trinomial, 1, 2, 3 parts. I'm going to put everything on the left side. So 2x squared plus 4x, this is 4x is going to move there, plus 4x, this 3 is going to move there also, and be a negative 3. So plus 4x minus 3 equals 0. Let's try factoring. A times c is 2 times negative 3, which is negative 6, and b is 4. 4 goes here. Two numbers that multiply to make negative 6, but add up to 4. Well, 1 times 6, that won't work. 2 times 3, that will not work. Well, I guess it doesn't work. So there's, again, we have a situation that you can't factor it. So you can't factor this and solve it. So how about we try completing the square? First step, move the 3 over to this side. So you're just left with these things here. Now remember, with completing a square, you cannot have a coefficient for the a value there. So you factor that out. 2 came out. Now we have this 2. Now you do b over 2 squared. In this case, b is 2 over 2 is 1. 1 squared is 1. All right, so that means if I write this out like this, in that space there, I can add a 1. That's the number I got here. And on this side, I have to keep the balance. But you're not going to add 1, remember, because we have this 2 out here. So the net result on this side is actually adding 2. So I should add 2 on this side as well. All right, this is now a perfect square trinomial, which factors into x plus 1. So we have 2 times x plus 1 squared, and this side adds up to 5. Now to solve this, it's solvable now. All right, that's great. Putting it in this form or vertex form by completing the square, let's just solve it. So first step, let's divide by 2 to move the 2 on this side. So divide by 2, divide by 2. I have this. Now we can take the square root of this and the square root of this to get rid of this square. So square root, and you're left with x plus 1 when you take the square root. On this side, don't forget the plus or minus so that we get two answers. Now this 1 is going to move over to this side and become negative 1. So we have x equals negative 1 plus or minus the square root of 5 over 2. That's two answers. I'm going to write them both out. Negative 1 plus root of 5 over 2 and negative 1 minus the square root of 5 over 2. All right, excellent. Now you know how to solve by completing the square. Please try the practice assignment that follows on our lesson. There's a small problem set, so you can practice this a few times. If you've been working on a lot of things already, at least try a few problems just to make sure you can do this on your own. Great job.